as long as I can remember. Even as a little kid, I loved to run. The rush I get from sprinting towards the finish line is unbelievable. Right now, I'm aiming for a new personal best, but it's going to take a lot of work to break my own record.
As my friend Derek can tell you, breaking records takes determination and a lot of heart.
Heart and lungs, you mean? As the anchors for the circulatory and respiratory systems, they keep your heart pumping and your lungs breathing. 'Cause this isn't any old race. This is the human body in action.
To get my mind focused and my body loose, I start every practice with a good warm-up.
The circulatory and respiratory systems don't need any warm-up. Throughout your life, this dynamic duo is always on the job.
Like the ultimate delivery service, the two systems combine to bring every cell in your body all the things they need to function and grow.
What keeps your body healthy and growing? Nutrients. And one of the most important is oxygen. Every time you inhale, you take in oxygen. Every time you exhale, you release carbon dioxide, or CO2. It's a gas exchange. On a microscopic level, every cell in your body is making that exchange too. In a process called cellular respiration, the cells use the oxygen to burn nutrients, unleashing energy. They also produce waste products, CO2 and water vapor.
Nutrients travel through the circulatory system. Also called the cardiovascular system, it's made up of the heart, blood vessels. Oh, and don't forget the blood itself. When you inhale, oxygen travels to the lungs, the main organs of the respiratory system.
In with the new, out with the old. The circulatory and respiratory systems also double as the body's cleanup crew. Waste, whatever the cells don't need, gets carried away by the blood to other organs of the body. Without the dynamic duo, a mountain of poison would build up in your body. Nasty.
I'd flown like the wind through that warm-up sprint, but now I had no wind left.
To replenish your oxygen supply, just breathe deep. The air all around you is about 1/5 oxygen. Let's take a tour of the respiratory system. Pick an entrance through your mouth or through your nose. Either way, you'll pass by the place where speech sounds are made, the larynx.
Next, we enter the windpipe, or trachea, as we scientific types like to call it. Whoa!
The trachea funnels us into the chest cavity where it splits into two smaller tubes called bronchi. The bronchi lead directly into the lungs. They keep branching off into still more tubes till they look sort of like the top of an upside-down tree. The branches are called bronchial tubes. The twigs are called bronchioles. And at the end of the twigs are...
Leaves?
Not leaves. There are actually 300 million tiny air sacs in each of your lungs. These balloon-like sacs are called alveoli. Altogether, they make up gas transfer central. Oxygen passes through alveoli to tiny blood vessels called capillaries. There, the oxygen gets snagged by red blood cells heading for the heart. Carbon dioxide from other red blood cells passes into the alveoli. They send that waste gas out of your body the same way the oxygen came in, through the lungs. The more oxygen taken in and carbon dioxide expelled with each breath, the more efficiently the systems can do their job. Vital lung capacity, the amount of air that the lungs can hold, is a runner's secret weapon.
What's your lung capacity? Here's a busybody experiment you can do to find out. Vital lung capacity is measured by the amount of air you can forcibly exhale from your lungs after you take a deep breath. It's one way to tell how strong your respiratory system is. You'll need at least 3 people and a few simple materials. A plastic dish pan big enough to hold about 4 liters of water. Several 60-centimeter long pieces of plastic tubing, at least one for each person you'll be testing. An extra large plastic jar with a lid, a graduated cylinder, water, masking tape, and a pen and paper to record your results.
Now, we're ready to make our vital lung capacity measuring device. Place a strip of masking tape on the outside of the plastic jar, all the way from the top to the bottom, and use the graduated cylinder to fill it up with water 250 milliliters at a time, marking the tape carefully at each level. Now dump that water out, turn the jar upside down, and label the lines. The top one should read 250, the next one down 500, the third 750, and so on. Next, fill the jar with water to overflowing and cap it loosely. Fill the dish pan about 1/3 full of water, and now here comes the tricky part. Place one hand on the jar's cap and the other on its bottom and place it upside down in the dish pan so that the lid is underwater. Have a helper turn the jar while you take the cap off, and be very careful not to allow air bubbles to enter the jar. Now slip one end of the plastic tubing up inside the jar, again being sure not to let in any air. Okay, now you're ready.
Can you tell how this contraption is going to allow us to test vital lung capacity? It's really very simple. Each person will take a deep breath and then blow into the tube as hard and long as they can. And that means really blowing all the way. No quitting early.
At the end of each test, you'll be able to see how much water has been displaced from inside the jar. Write these numbers down in your notebook. To test the next person, just start again with a full jar, and be sure to use a new tube each time. Test each person and write down the results. Just to be sure you've done an accurate test, have each person do it several times, and use the highest number for each.
What you'll find is that there are differences in lung capacity from person to person. An average 13-year-old boy will probably score about 2,500 milliliters, while girls average about 2,400. A healthy young adult man should be able to displace about 4,500 milliliters, with women averaging around 3,000.
A number of factors, including age, gender, and fitness, can definitely influence your vital lung capacity.
And you were actually able to measure this important health factor without fancy expensive equipment, but by using plain old everyday stuff. Pretty cool.
Derek prides himself on the strength of his legs, but the muscle that really keeps him going is his heart. About the size of a fist, it's the engine that drives the circulatory system. It contracts and relaxes constantly without any thought on Derek's part at all. Over the course of his life, this tireless pump will beat over 2 billion times. And while Derek's heart beats about 72 times per minute at rest, during a long-distance run, his heart rate increases dramatically.
Phew! Why does it have to work so much harder?
It's the mystery of the increasing heart rate. To solve it, we'll have to take a closer look at the heart and its vast network of blood vessels. A thick wall divides your heart into 2 halves. The right side gets oxygen-poor blood from the body and pumps it to the lungs to pick up fresh oxygen. The left side of the heart gets oxygen-rich blood from the lungs and pumps it to the entire body.
Here's a good way to remember your right from your left. Blood leaving from the left has really left. It's got a long ways to go. But blood leaving from the right will be right back. After all, it only went to the lungs.
Each side of the heart is also divided in 2, creating 4 chambers in all. the left atrium and left ventricle, and the right atrium and right ventricle. Like doors between rooms, sturdy valves separate the chambers. Blood pushes against them, forcing them open and closed. The valves keep the blood traveling in one direction, from the atria and into the ventricles and out of the heart.
The opening and closing of the valves is what makes that lub-dub sound in your heart, better known as your heartbeat. It's what doctors hear when they listen to your chest with a stethoscope.
The vessels leading out of the heart are arteries. The biggest ones, the aorta and the pulmonary artery, are about as thick as your thumb. Strong and elastic, healthy arteries stretch whenever your ventricles pump blood into them and then spring back between beats.
How can you check the beating of your heart without using a stethoscope? By taking your pulse.
Your pulse is the throbbing of your arteries caused by the beating of your heart. To find your pulse, you have to locate an artery. The easiest one to find is in your wrist. Use your index and middle finger of one hand and gently press them against the outer edge of the inside of your other wrist near the bottom of your hand. You should be able to feel the throb of your heart beating as it pumps blood through that artery. Now, have someone time you while you count the number of beats you feel in 10 seconds. Write this number down in your notebook, multiply by 6, and that's your heart rate.
When you're resting, your pulse should be somewhere between 60 and 100, depending on your age and physical fitness level.
Now, let's see what happens to your heart rate when you work your body a bit. Exercise for about 1 minute by running in place or doing jumping jacks. Now, check your pulse rate again. You'll find that your heart rate is now much higher than it was when you were at rest.
That's because your cells burn more oxygen when you're active, so your heart has to pump faster to keep up with the demand. Hey! The faster Derek runs, the more quickly his cells use oxygen. His heart has to pump harder and faster to keep up with the demand. Finally, we've cracked the case of the increasing heart rate.
That's right. And the stronger your heart is, the more efficiently it can do the job. So it pays to keep your heart healthy.
Hang on to your history books. Here comes a body blast from the past.
Whenever you're doing any kind of activity, like running, jumping, or even just playing a video game, your heart is always working. It constantly has to circulate your blood throughout your entire body, and that is no small task. A good way to find out how well your heart and arteries are doing their job is by checking your blood pressure.
Thank goodness for man's best friend. A dog helped pave the way to a better understanding of blood pressure. Early in the 20th century, Russian doctor Nikolai Korotkov was performing experimental surgery on a canine patient. As he removed a tourniquet, he noticed a force at work as the dog's heart was beating. The force of the blood flowing against the artery walls created pressure. The pressure was greater when the ventricles contracted and blood surged into the arteries. The pressure was less in between beats when the ventricles relaxed. In 1905, Korotkov published his findings and applied them to people. Many folks back then thought he was crazy, but today, everyone uses his method.
One of Korotkov's biggest contributions to science was his invention of the blood pressure cuff. It represents blood pressure as one number over another. The first number of a blood pressure reading represents the maximum pressure caused by the surge of blood from the contracting ventricles. The second number represents the reduced pressure when the ventricles relax. Arteries are the superhighways of the circulatory system, but like highways that branch into smaller side roads, arteries get tinier and tinier as they spread out. Finally, they turn into the footpaths of the system, the capillaries. Reaching even the most remote parts of the body, some capillaries are so narrow that only one blood cell can pass through at a time.
Artery walls are multi-layered and muscular, but capillary walls are single-layered and thin. Oxygen, other nutrients, and waste products can pass right through them, to and from all the cells in your body.
After the blood makes its pickups and deliveries, it needs to get back to the heart. It makes the return trip through the veins.
So, arteries carry blood away from the heart. Capillaries connect the arteries and veins carry the blood back home. And boy, is it a long trip! As it circulates your body, blood can travel through up to 100,000 kilometers of blood vessels. That's like circling the Earth twice. A single drop of blood can leave the heart, make its delivery to the body's cells, and return to the heart in less than a minute. What's the rush? Blood needs to return to the heart.
It goes to the right side where it's sent to the lungs for more oxygen, the gas that cells need to burn nutrients for energy. Then the blood travels through the pulmonary vein to the left side of the heart. It gets pumped through the arteries back to the body cells to make fresh deliveries.
That massive highway system of blood vessels gives every cell in your body access to oxygen and other nutrients, and takes care of waste disposal. So what are the vehicles traveling these roads? Blood, the third component of the circulatory system. Its main jobs are to transport oxygen and other nutrients to the body's cells, pick up wastes from the body's cells, and defend against disease. And whoo boy, is traffic heavy! In just one drop of blood, there are about 5 million red blood cells, 8,000 white blood cells, and 250,000 blood-clotting platelets. And just think, you've got nearly 4 liters of blood coursing through your vessels. Those are some serious numbers. In fact, there are more red blood cells in your body than any other type of cell.
But blood isn't just cells and platelets. More than half of it is a yellowish liquid called plasma. About 90% water, plasma contains stuff like dissolved proteins, vitamins, and minerals like salts. Nutrients all cells need to grow and function.
Just as other athletes at Derek's school have different specialties, the 3 different parts of blood also have different tasks. First and foremost are the circulatory system's workhorses, the oxygen-bearing, CO2-removing red blood cells. Where do they get that fabulous color anyway?
Red blood cells are full of hemoglobin, a protein jam-packed with iron which just happens to be the mighty oxygen magnet.
Oxygen magnet?
In the lungs, the iron in hemoglobin bonds to oxygen, turning the cell bright red. On its way through the body's tissues, the cell releases the oxygen and picks up CO2. Without oxygen, its color fades. Seen through some veins, like the ones in your wrist, your oxygen-poor blood actually looks blue. It's not easy being the taxi service for billions of cells. Blood cells only live about 4 months before they're taken out of commission.
But you won't even miss them. In your bone marrow, about 2 million new red blood cells are produced every second.
White blood cells are far less abundant. Only 1 for every 750 red blood cells. But they make up in strength what they lack in numbers. For white blood cells are your body's fighting force. Who takes on all the disease-causing microorganisms that infiltrate our bodies?
The white blood cells.
Who is the foiler of fungi, the bane of bacteria?
The white blood cells.
Who helps vanquish viruses and punish protists?
The white blood cells?
You got it! When you need them, these cells multiply like crazy. They wage war on all intruders, often dying in the process. Most white blood cells only live for a few days.
Should Derek stumble and fall while running, another key member of the blood team is ready to spring into action. Platelets in the blood rush to the site of a wound and form little protein threads called fibrin. Like a net, the fibrin traps red blood cells and more platelets. The bleeding stops. Next thing you know, you've got a scab, and your wound is healing.
Red blood cells, white blood cells, platelets, and plasma. Blood is critical to keeping us healthy, fighting infections, and healing wounds.
Studying blood and how it functions is the job of Dr. Kim Smith-Whitley, our science star.
My name is Kim Smith-Whitley. I see children with blood disorders as a pediatric hematologist. A number of the patients that I see need blood because they have problems that they were born with or developed through their lifetimes. And some of our children come into the hospital once every 3 to 4 weeks to receive a blood transfusion to keep them healthy. I think the thing that is so incredible is that by donating 1 unit of blood to somebody, to a donor supply center, you're actually donating red cells, you're donating platelets, and you're donating plasma. And those products can benefit not one person, but many people. People donate blood primarily by going to a blood donor center. What we do is when the individual comes to the donor center, there is a small vial of blood that is taken at the same time that they are actually donating a unit of blood. When that small tube goes to the donor center, they actually do a series of tests. Blood typing is important because everyone is different, just like there are a number of people that have different color eyes. Some people have brown eyes, some people have blue eyes, some people have black eyes. You can be blood type A, B, O, or AB. So what we try to determine first and foremost is what that ABO typing is. People have red blood cells that have proteins that sit on them that say, I am Kim Smith-Whitley, or I am John Doe. It's important that they receive blood from individuals who have blood proteins that are similar to their own. Because if that is not the case, then your body can actually react to the blood in a bad way and make you very sick. I think people donate blood for a number of different reasons. They realize that there are people who get in car accidents, who have surgery, who have illnesses beyond their control that need blood to keep them healthy and alive. They are donating blood out of the goodness of their heart to help their fellow man.
Derek races for fun and glory, but many people are in a race against time. If someone you know is able to give blood, let them know how important it is.
Right now, Derek's heart is furiously pumping his blood into his arteries. Carrying oxygen to those hard-working muscles, the red blood cells pass into the capillaries and make their delivery. They pick up carbon dioxide and make a getaway through the veins back to the heart.
Throughout the circulatory system, the plasma in Derek's blood is transporting nutrients from the food he eats to hungry cells, while his white blood cells and platelets stand by to protect him from disease and injury.
As he comes into the stretch, Derek pushes his respiratory system to the limit. His lungs exchange the oxygen he inhales for the carbon dioxide his cells have produced.
Yes, a new personal best.
All it took to reach the goal was a lot of heart.
A pumping heart and breathing lungs. The dynamic duo of the circulatory and respiratory systems. They keep the human body in action.